Okay, we've done solving systems of equations already, so we're going to start out down here, but then we're going to use some matrices to do this. So when we do this, subtract that x to the other side, get y equals 1/2 x plus 2. So I come down here to 2, and it's a positive 1/2, up 1 over 2. Okay, I don't need all of these, but there we go. And let's go back up here. Subtract the 3x from both sides. So I go down to -5. 1, 2, 3, 4, 5. 1, 2, 3 over 1. 2, 3 over 1. Look at that. They ran into each other. That was a horrible line. Yeah, I can't even deal with that. It was ugly. There we go. Okay, so where did they run into each other? At -2, +1. So that's the solution for that. Now let's come over here. Substitution or elimination method. I think I'm going to do, I don't know, let's do elimination. So I'm going to multiply this one by 2, and I'm going to get 6x plus 2y equals -10. Bring down the other equation, equals -4. Add those, 7x equals -14, so x equals -2. I plug that back into the first one. I get -2 minus 2y equals -4. I'm going to add 2 to both sides. I'm going to get -2y equals -2. So I'm going to get y equals 1. So -2, 1. Look at that. Maybe look at that. Come on. Look at that. They came up with the same answer. That's because they're the same equation, or the same system of equations. So we're now going to take that same system of equations right here, and what we're going to do is we are going to solve it. So here is our system right here. I don't know why I did that. This is our system. The first matrix, this is called the coefficient matrix. And then we have the variable matrix. And then we have the constant. And if you notice, this is in standard form. Make sure it's in standard form. Okay. So now what we have to do is we have to come down here. Now, if you were to we're not even looking at those words. If I was to solve this equation right here, I would divide both sides and get x equals 2. The problem is you can't divide divide matrices. So this right here was called our multiplicative inverse. So what we need to do is the same thing. We need an inverse. Okay? This is how you denote inverse in matrices. Sorry. So what's going to happen is if I take the matrix, I multiply it by its inverse, I'm going to come up with the identity. So remember, identity for a 2 by 2 looks like this. Okay? So now we have to figure out how to make the identity. So the very first thing we're going to have to do is we're going to have to find what is called the determinant. And I messed this up in class today, but the determinant, you write it as, it looks like the absolute value of A. But A is a matrix. And so we write it with the absolute value symbols, but it's meaning the determinant, or you can write DET. So what we're going to do right here is we're going to find the determinant. So 1, -2, 3, 1. Notice how these bars are straight up and down bars. Then what we're going to do, so the matrix A is A, B, C, D. What we're going to do is we're going to take A and D, we're going to multiply those together. Then we're going to take B and C, and we're going to multiply those together. Then we're going to subtract those numbers. So here we go. We're going to take these two, and we're going to multiply them together. Then we're going to subtract, and then we're going to multiply these bad boys together. So I have -2 times 3. And when I do that, I get 1 minus a -6, turns to a plus sign, so I get 7. So my determinant is 7. Okay? Now, in order to find the inverse of that, okay, so now we're going to find the inverse. Okay, we have the matrix that we started with. We found the determinant. Now, this right here is our inverse. So, what we're going to do is we're going to put, we're ignoring what this says here, 1 over the determinant. Then we have to do a switcheroo. So if look at this right here. We switch A and C, or sorry, A and D. You switch those around. And then look at this. B and C are the opposites. Okay? So, here we go. 7 was our determinant, so we do 1 over 7. Then we take this matrix right here, these two switch. Well, that's easy, 1 and 1. Then these two right here, you do the opposites. So this is 2, this is -3. So if I was to multiply it, because this is scalar multiplication, I would get 1/7, 2/7, -3/7, and 1/7. Like so. So remember, in order to solve this, we need to multiply our inverse on both sides of the equal sign. So 1/7, 2/7, 1/7, 2/7. I know I need to make this bigger. -3/7, 1/7. -3/7, 1/7. Okay? So that's the left-hand side, but I also have to do it on the right-hand side. So 1/7, 2/7. -3/7, and 1/7. Now, the whole point that I told you about a minute ago is when we take the inverse and we multiply it by the original matrix, you're going to get the identity. So, when I multiply these two together right here, I should come up with the identity. So, let's multiply those two together. Okay? So, I'm going to take 1/7. I'm going to take 2/7. I'm going to take -3/7 and 1/7. And we're going to take 1, -2, 3, and 1. And we're going to multiply. And I like to show my work off to the side. So 1 times 1/7 is going to be 1/7. 2/7 times 3 is going to be 6/7. So that together is going to get me 7 over 7, which is 1. Then I'm going to take 1/7 times negative 2 and get negative 2/7 plus 2/7. And that's going to get me 0. And then I'm going to go on the bottom and I'm going to do negative 3/7 plus 3/7. That'll get me 0. And then I'm going to do 6/7. Yep. Plus 1/7. That'll get me 7 over 7. Okay, so now I'm going to erase my extra work. Erase all this because I don't need any of that now. And this, and this. And I can make my matrix. Okay, so did I get my identity? I sure did. So I'm going to bring that down here so I have my identity matrix right here. That got rid of this part. So now I just have this to multiply and then equals. So now I need to come over here and I need to multiply these. So 1/7, 2/7, negative 3/7, 1/7. Sorry, I have to copy this down. And then, I don't know why I'm doing another color, but I am. Negative 4, negative 5, and okay, so that's going to get me negative 4/7 minus 10/7. So it's going to get me negative 14/7, which is going to get me negative 2. And then I'm going to take negative 3/7 and multiply it by 4 and get 12/7. And then minus 5/7. And that'll get me 7 over 7, which is, oops, not 7, but 1. Okay, so let's undo that. So that got me this. So I'm going to bring this down here. Negative 2 over 1. And remember, when you multiply the identity, you're just going to get this. Okay, so that means I have this. So that means the x is equal to negative 2. The y is equal to 1. And that's what we found. It's the same exact thing we did a minute ago. Now, some of you may be saying, I really, really don't like having to multiply by that 1/7. Well, let me show you a trick with that so you don't have to multiply by all those fractions. Okay, so we're ignoring this right here. Okay, so the inverse that we found a minute ago was 1/7 times, and now I have to remember, 1, 2, negative 3, 1. 1, 2, negative 3, 1. That was the inverse. So if I took that, 1, 2, negative 3, 1, and I multiplied it by the initial 1, like so. Oops. 1/7, 2, negative 3, 1, and black. And I forgot what it equaled. Negative 4, negative 5. Okay. If I did it like this, because with multiplication, with the scalar multiplication, you can wait. Alexa, stop speaking. With the scalar multiplication, you can do that at the end. So let's do this and do that part at the end. So we're going to do 1/7 over here. So 1, 2, negative 3, 1. And then we're going to do 1, negative 2, 3, 1. Okay? And we're going to do this, and we're going to do this. just like we were doing before. And so that's going to give me 1 plus 6, which is 7. And that's going to get me negative 2 plus 2, which is 0. And then down here is going to get me negative 3 plus 3, which is 0. And then 6 plus 1, which is 7. Okay, so now I'm going to erase all of my extra work. There we go. Now I have to remember that I still have this scalar out here, so I have to multiply that. Look at that. Didn't I get the identity? So I'm going to write it down here. So now I have 1, 0, 0, 1. I can bring down my x, y. I can bring down my equals. Now let's come over here and do this scalar multiplication. This multiplication. Okay, so this is 1, 2, negative 3, 1. And this is negative 4, negative 5. And we're going to do this. So that would get me negative 4 minus 10, which is negative 14. And then this would get me 12 minus 5, which is 7. Okay. Remember, I still need to do my scalar multiplication. So when I do this, when I do that scalar multiplication there, I'm going to get negative 2, and I'm going to get 1. Come on. So in the long run, what color do I want to use? I'll just write it right here. XY, negative 2, 1, which is the exact same thing that we did up above right here, but with fractions. So if you don't like dealing with all the fractions, you can do it this way. Okay, you can do it this way instead of dealing with all the fractions.